Hello, Science 8. Miss Richards is helping me video today. I miss you, Little Lou, as my videographer, but Miss Richards is great too. So what we're going to do today, well, in the previous investigation, you used an ammeter to record measurements within an electrical system. In this investigation, you will use a voltmeter, which I have here, and you're going to use it to record measurements in an electrical system. So remember, the voltmeter has a V, and that V stands for volts. So now we're going to examine one of the batteries we'll use during this investigation. The voltage measured in volts depends on the type of metal from which the electrodes are made, and is determined by the difference in the positive and negative charges on the battery terminals. So if you want to look at your sheet, remember the electrodes. We have a zinc electrode, and this is a dry cell battery. So we have a zinc electrode sort of on the outside, but it's encased by the metal covering. And then we have a carbon rod electrode that's seen in the middle right here. And yours is colored, and you're able to see that better on yours, but I just wanted to point those out. Remember, in the dry cell battery, or in the wet cell battery, we had these two electrodes. So we had the copper electrode and the zinc electrode. We put this in the copper sulfate solution, and the copper sulfate solution was our electrolyte in the wet cell battery, and then these were our electrodes. But in the dry cell battery, you have the paste around your electrode, and it's encased in metal. So the rest of your sheet says voltage is the measure of the work required to move an electric charge through a circuit, and voltmeters are used to measure the voltage. So I reminded you of those definitions. So number one says to carefully examine the voltmeter above, and then I've got one here for you. How is the ammeter, how is it similar to the ammeter? So you want to show them this a little closer. Thank you. And then also answer number two, how is the voltmeter different from the ammeter? So look at it and try to determine that. So you can pause this for a second if you need to, and then come back, but we're just going to move right along. So the number three question says, what units of voltage does the voltmeter measure? So use the reading above, or use the information in the reading above. So the reading on page 1 to answer that question, because I told you that on there in the definitions. Now number 4 says, what range is on the voltmeter scale? So we want to say, so what range? It goes from 0 to 5 volts. So you're going to put 0 volts to 5 volts. And then how much voltage does the smallest mark on your voltmeter represent? So we have 0 to 1, and then in between 0 to 1, we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 little tick marks. So if we're going, if 1 is the voltage, and we have 10 tick marks between 0 and 1, then 1 divided by 10 is 0.1. So the smallest tick mark measures 0.1 volts. So if we say 0.1, 0.2, 0.3, 0.4, 0.5, 0.6, 0.7, 0.8, 0.9, we'll get to 1. So the smallest tick mark is 0.1 volts. So now the directions say, a system of, oops, I should have moved the desk. So a system of a circuit will now be set up with a battery and a voltmeter seen in the figure below. Think about how you would draw the schematic of the system using the symbols from 2.1. So I've got that, so you think about that. I've got that drawn out over here. So hopefully, as you were thinking, you came up with this information. So here's the schematic of the battery, which is right here, and the voltmeter. And remember, we want to hook up the positive end of the battery to the positive end of the volt, and the electrons are going to go from positive to negative. Okay, so I'm going to now set up the voltage. So I have brand new packs of batteries. I've got 3 packs of Dollar General's Finest, and then I have 1 pack of the D-Cell Energizer Max batteries. So I'm going to use the Dollar General Finest first, and I'm going to set this up. So I've got 1 battery, and I'm going to put it in, so negative on the spring end, and then positive is going to be set up to the positive end. So I've got my alligator clip, positive to the positive. So I need to unscrew this so metal can be attached to metal. And then I've got negative going to the negative terminal. So number 6 says to record the voltage that is measured across the battery. So this voltage is about 1.7. Is that what it looks like there?
Yeah.
Okay, so you're going to write down 1.7 volts. It says above that, the wires will now be connected with the positive terminal of the battery connected to the positive terminal of the voltmeter. If the voltmeter reads a positive number, the battery and the voltmeter are connected properly. So it was a positive number, so it's connected properly. So we should be in 6th period, I think. Welcome. So change the battery out and record the voltage for each. So now, so that was battery 1. I'm going to put it over here. We'll see what battery 2 is. So now I'm going to use the Energizer D Max, and we'll see what that measures. So we're going to see which is actually better, or if one is better than the other, and if you can save some money using this, using the Dollar General battery. So let's record what battery 2 is. Whoa.
It's not pushed in there all the way, I don't think.
Is it not? Oh, no, it isn't. Thank you. Okay.
About the same.
Yeah, it's measuring 1.7 volts again, so make sure you mark that down. So 1.7 volts for battery 2. And if you remember, D-cell batteries are supposed to be 1.5 volts, but these new ones, it looks like they're registering 1.7 volts. So we'll do battery 3 now. And we'll wait till it stops moving. So it also looks like it's 1.7 volts. And then battery 4, we'll get a new check. So here's battery 4. Okay. And it's also 1.7 volts. So we were pretty much the same throughout. So 1.7 volts. Okay, let's go to page 3. So number 9 says, is the voltage the same for all batteries? So answer that now. And then if voltage was the same for all batteries, why was it the same? If the voltage was different, why was it different? Okay, so these are all the same because they came out of the packages. I showed you that I was opening the packages, but what if these batteries are older? Do you think that they would have the same voltage if some of them were older and some of them were right out of the package? So tell me about that. So ours were the same. They were the same because they were all brand new. And then why do you think that they would be different? So think about what you think the batteries would register as in voltage if some of them were older instead of right out of the package. So number 11 says predict how voltage across one battery will compare to 2 batteries connected in a series. So now we're going to take 2 batteries and connect them. So I'm going to unconnect. Well, you make that prediction first. Then also predict on number 12 how voltage across one battery will compare to 2 batteries connected in a parallel. So make that prediction now. Now on number 13 it says use the materials to build a series circuit with 2 batteries. Record the voltage measurements below. So if you remember from the first, we said that the voltage of one battery was 1.7 volts and the voltage of two batteries in a series. So I'll show you the schematic of the series, the two batteries connected in a series. So we have two batteries. Here's one battery, here's the second battery, and remember a series is in line with one another. We're going to have the positive end still connected, or the negative end still connected to the negative end of the voltmeter, and positive connected to the positive end of the battery. So okay, so I'm going to disconnect the battery, and remember I want to keep the type of battery, the brand of battery constant. So I'm going to use the same brand. I'm going to use the Dollar General brand and connect it, or put it in the battery holder. And remember I told you that they have these snaps, the battery holders have these snaps on them. So I want to go from positive to negative so the flow is the same. And now I can connect my series, my two batteries in a series. I'm going to connect the positive end to the positive end of the voltmeter. So when I do that, one battery was 1.7, and then it's showing that two batteries, the voltage is 3.225. Yeah, so we'll round up to 3.3. So the voltage of two batteries was 3.3 volts. Okay. Now number 14 says, did the results support your prediction? So look back at number 11, look at your prediction and say yes or no if your results supported your prediction. Now on number 15, it says use the materials to build a parallel circuit with two batteries, record the voltage measurements below. So remember, one battery is 1.7 volts, and now I'm going to disconnect these, and I'm going to connect two batteries in parallel. So with parallel, this is what the schematic looks like. So you have one battery here and one battery here, and I'll show you compared to a series, the two batteries in series. So here's what it looks like in series, here's what it looks like in parallel. So you have them stacked on each other in parallel. So I'm going to take these apart. Remember, when you're moving batteries around, you need to disconnect things or open your switch, but we don't have a switch in this case. So I'm gonna take these batteries and piece them together like I did in 2.2. Okay, so here are the batteries in parallel. So again, the positive end here needs to be connected to the positive end of the voltmeter, and then I connect the negative end to the negative end of the batteries. So now it still looks at 1.7. So two batteries in parallel, it's still 1.7 volts. So now it says on 16, it says, did the results support your prediction? So look back at number 12 and say yes or no whether the results supported your prediction. So in parallel, the voltage is staying the same. In series, the voltage is almost doubling. So now it says, predict how voltage across one battery will compare to three batteries connected in a series. So make your prediction there. And then also number 18, predict how one battery will compare to three batteries connected in parallel. So predict for three batteries in parallel and three batteries in series. So let's go to the next page. So use the materials to build a series with three batteries and record the voltage measurements below. So here's the schematic of three batteries in series. So you've got 1, 2, 3 batteries in this schematic. So we're going to take these apart. I'm going to get my third series, or third battery for the series. And remember, series is in line, so I connect the snaps. Sometimes these are hard to keep together, so. And then the positive ends are down here, so I'm going to connect positive to positive. And now I'm going to connect negative to negative. And when I do that, it's beyond 5, so we can't even measure. Is it 5?
It's
Yeah.
low.
It's so what we're going to say is one battery was 1.7, and then the voltage of 3 batteries was greater than 5 volts. So 1.7 volts and greater than, that looks like a 7, but greater than 5 volts. So did the results support your prediction? So answer that. Now we're going to build a parallel circuit with 3 batteries. So I'm going to take these apart and then put these in parallel. So remember, I've got to fix these where metal is on metal. Okay, there's 1 and 2 connected. And now, let's see. Now the 3rd is connected. So hopefully you've already made your prediction. Don't cheat. So positive is going to be connected to positive and negative to negative. So now we're still registering at 1.7. So 1 battery in parallel was 1.7 volts. 3 batteries in parallel was 1.7 volts. And did the results support your prediction? So write that there. So now we have a data table. So it says use the data from above to fill in the answer, or fill in the table below. So we have number of batteries in a series, 1, 2, and 3. So let's look back at our data from the series. So 1 battery was 1.7, 2 batteries was 3, I'm writing upside down, 3.3, and then 3 batteries was greater than, oh goodness, I don't know if I can do a 5 upside down, greater than 5.0, okay? And then with the batteries in parallel, we had 1.7, 2 batteries was 1.7, and then 3 batteries in parallel, the voltage was 1.7. So now it says, look at the data table. What happens to voltage when you add batteries in a series? So what happens to voltage? So do you see a pattern there? So as you increase in voltage, what's happening? Or as you increase in batteries, what's happening to voltage? Number 24 says, look at the data table above. So the data table on the previous page. What happens to voltage when you add batteries in parallel? So what's happening to voltage as you're adding batteries? So 1 battery was 1.7, 2, 1.7, 3, 1.7. So answer number 24 based on that. Now you have a grid. It says use the grid below to make a graph to show the pattern in your data. Be sure to label the axes and include a title. So what I'm going to do is I will create another video where I'm videoing my screen, and I will help you with that. So skip that for right now, and then go below the table where it says, when we connected 2 or more batteries in series or parallel, we created a compound battery. Look at the voltage measurements we recorded and use this information to answer questions 25 through 30. So you should be able to answer those on your own. Just look back at your information that you have and answer 25 through 30. And once you're done with that, you can go to the video where I have the graph information. I'll name it EWIT lesson 2.3 graphing information. So I hope you enjoyed this video. I miss you all very much, and I will hope to see you soon. Bye bye.